Now we'll go through some of the content here a little bit faster, but my main goal of this presentation was to try and give you more of an in-depth overview of the UPG, the Universal Post Generator, and looking at maybe the EC Editor as well, just to kind of explain a little bit more about how that works and where some people go wrong with that. So main content for today is, let me just make sure it's on the screen there, is basically go over what is a post processor. Some people are unaware of what they actually do and how it actually works, and we'll often get tech support calls coming in saying, hey, this is a post problem and it's doing this and it shouldn't be doing this, and when in reality it's actually a software programming issue, so it's something inside of CAMWorks that hasn't passed through to the post. So we'll look at what is a post processor, what is it doing, why do you want to customize it to start with, why do you want to use the UPG, what sort of reasons we see for customizing your post. Looking at the UPG and the EC Editor, see what those two different softwares do, what you can do in one versus what you can do in the other. Looking at the actual full range of files that are used in the post-processing creation and compiling process. We'll explain what each of those files do and where they are to find them, and so on and so forth. And then we'll look at creating a post using the UPG. We'll go through some of the menus, look at some of the functionality, what you can modify, where you can modify, how you can turn things on, turn things off. Explain a little bit about kind of where the sections are and how they're coming out in the code and how the UPG is structured to help you edit the post. Then also looking at some more custom in-depth edits with the EC Editor. What can we do outside of the UPG to customize a post and make it work for our needs? So what is a post processor? What is it going to do? Well, a post processor is essentially a driver or a translator to convert the toolpath that you see in CAMWorks into a format for a particular machine to read that particular code. So essentially we start off with our CAD file. We draw our CAD file in SolidWorks or in a 3D CAD package. We open it up, load up on the CAMWorks add-in, and basically start programming our toolpath. Now at that point, it doesn't know what machine that toolpath is going to be sent to. It doesn't know what format the code needs to be in, and that's where the post processor comes into play. So when we go into CAMWorks and select that post processor, we've got specific functions in that post processor to say, okay, well, do this if you're doing a drilling cycle, or turn the coolant on in that particular post, and what does that coolant option mean to the machine. It will translate that setting in the interface to an output in the code, so you can run your CNC control. Why do we want to customize them? Often, many different reasons. Maybe simply the code doesn't run on the machine. Maybe we've got a template post, or we've used the UPG and we've got something, but there's some errors coming out on the controller when we load the controller. Maybe the compensation's not on, or it's in the wrong spot, or the G43 line doesn't have a Z move on it, or something like that. We can also use it to prevent CNC startup issues. So I've dealt with it many times in the past where maybe a previous operator has been working on the machine. They left their spindle, I don't know, halfway down. Their offsets are all still called. They're still running like a G54 in the machine, and you've not had your coffee that day. You hit Z0 and it just goes straight to the table. And basically we can set up some stuff in the code at the very top in the header. We can set up a safety line to cancel certain codes, make sure everything's starting off so it's got no can cycle controls using a G80, no length offsets in there, no work offsets if we wanted to, or we can set a specific work offset. And then maybe we can send it home at the beginning of the code as well, just to make sure that it's all up there, ready, waiting to go, and nothing's kind of going to be running straight down and into the table there. The other things we can use it for is maybe we want to use specific hardware, such as either rigid holders or tooling with through cooling capabilities or something like that. or a particular function on the machine. Maybe we've got, I don't know, a chip conveyor or something like that we want to control. We want to turn it on at the start of the program, so it's automatically clearing the chips out and dumping them in the container for us. Another reason may be just preferences, user preferences. What do I want to see at the top of the code? Do you want a tool list up there? Do you want to see the programmer name? Maybe you've got a company where you've got 10 programmers and you don't know which code that particular program came from. Now, if you've got to spend 2 hours walking around trying to find the person that actually produced that code, it's just a waste of time. So we can now put things like that into the topper, into the header of the code, and basically make it more usable, so more easily understood to everyone, so everyone's on the same page, and everyone knows how that program is being set up. So what is the universal post generator? What does it do? Essentially, it allows you to create and edit post processors. It's a very simple user interface. If you've ever opened it up and looked at it, it's a little bit of an older style interface. It's more like an older style Windows style interface, but it's basically a series of checkboxes, drop-down menus, or user inputs where you can go and basically select some common user preferences, and it gives you the ability to go in and edit specific sections of the code. And we'll talk a little bit more about what the sections are a little bit further on in the presentation here. The other bonuses are that it requires little or no knowledge of programming language. So you don't need to understand if statements, then statements, and kind of all the logic in the background, if you will. It's a simple tool that allows you to customize it in such a way that you can get some of the basic changes done. You can't do everything in there. The EC editor is there for doing full customization of all the programming language and everything else. But we always use the universal post generator regardless of whether we use the EC editor or the UPG for creating the post. We always use the universal post generator for compiling the post processor to create our CTL and LNG files. So what is the EC editor? The EC editor is essentially just a text editor. You can open up the src files, the lib files in Notepad or some other Notepad editing tools. The nice thing about the EC editor is it's got the language that CAMWorks uses. So things like thread pitch and rapid planes and clearance planes. It's got all of that. Those variables that calculated from CAMWorks actually highlighted in blue, and it's got certain calculation functions like if and then highlighted in red. So you can tell if you actually got the code right just by looking at the color coordination of the lettering in the EC editor there. It does require some knowledge of basic programming. Essentially, the main focus of the programming is using if and then statements. If, then, else, do this, do that, basically. It's not like Visual Basic or any kind of C++ or anything like that style programming like a lot of posts are. It's very much a man-readable code, if you will. The EC editor, the benefit of it is it allows that in-depth customization. So we can go in and create custom fields in the posting tab in either the operations or the machine or in the setup to create specific functions, to create drop-down menus, to create new post operations. If we wanted to go in and put, say for instance in a lathe, we want to put bar feeder, bar pullers, and that kind of information in, we can create operations in the interface in CAMWorks, and you'll get a new post operation option on the right-click menu to insert a new operation, and we can dump blocks of code in and control exactly what the format is and everything else. We can also change all of the G and M code. So if like a G code is coming out, or an M code, like say for instance the through tool is coming out with an M50, and I need it to come out with an M88 or M89. You can go into the EC editor, go look at what the codes are, and then go see what the value is and change that value so it comes out in the code. The other thing we can do in the EC editor, and one of the main reasons, is we can either create new calculations and create new sections to go to. So if I have a specific section of code for maybe drilling. Maybe you've got a router that needs a certain spindle call or something like that for the drilling head. We can go and create a new tool change section that goes, okay, if you're doing a drill operation next, go and pull this particular section of code. The other thing we can do is redirect existing sections. So if we're saying, okay, go through the, I don't know, the rapid from tool change section, or if we wanted to go through a rapid to the tool change section, we can go and redirect those calculations and adjust those calculations to push it in a different direction away from where it is by default. So essentially, just to outline the process of creating a post-processor in CAMWorks, there's a bunch of files which I'll go into a little bit more in detail, and they're classed as the source code. That's the SRC stands for source. So that's your source code. That's the underlying man-readable language or person-readable language, if you will. We then use the UPG to compile that code, just like a Windows software or any other software. You compile that code so that it becomes a specific post-processor, and that compiling process takes that source code, creates the CTL, the LNG post files, and then that's what we select on in the software, and those are the non-man readable or non-person readable code. So what are the different files? So there's a wide range of the different files, and I've just broadly split them up into the uncompiled side of it and the compiled side of it. So when you go into the universal post generator and you go file save as, and you give your source file a name, say HOSVF3, it'll go HOSVF3.src. It will also name the HOSVF3.lib. When you compile that post processor, there'll also be HOSVF3.ctl, HOSVF3.lng when you compile it. But there are a bunch of other files that some people don't know exist or aren't aware of what they do. The mil.lib is a major file for where all the calculations exist. I'll go through that a little bit more. The master ATR and the mil.t32, they are all in the default UPG mil source folder. So when you go into and install your universal post generator, you'll get probably either a C drive UPG folder, or you'll get a program files x86 C drive UPG folder. And all of those files are in here. So you'll see the master.atr, the mil.lib, and the mil.t32 are all in here as well. The other files on the compiled side are a .pinf, and then a couple of RTF files, which are just text files to explain a little bit more about what you set that post up to be. So looking at just the uncompiled files, so postname.src, so HOSVF3.src, that's controlling the main user preferences. So if I want spaces in the code, if I want tool lists and stuff at the beginning, I can set that up in the top there. And it also controls which codes are called in the particular sections of the post. So if I'm going through a tool change section, what codes are called in that section? That's where you'll see your M codes, your G codes, your X, Y, and Z moves. Your postname.lib or HOSVF3.lib, basically that defines variables. So the variables are what give the prefixes. So when you see X1, Y1, Z1, the prefix X, Y, and Z are all being controlled in the format of the postname.lib. Same thing with things like coolant types. Define a coolant type, and then it will output as a variable into the post side, which you can call. So you define those variables in the lib file. You also create custom calculations for that particular machine or that particular equipment in the postname.lib, in the HOSVF3.lib. The mil.lib always remains named as mil.lib. What that file is it contains a list of all the generic variables, so all the standard variables, all the standard calculations for every single post processor created. So when you say, okay, the post goes through the initial header of the program, then it goes through the tool change, and then it goes through the rapid from tool change, and then it goes down to your rapid in Z. All of those calculations and all of those directions, if you will, are all coming from that mil.lib, and that's what CAMWorks updates when they give you new functionality and with new releases. So as an example, if you take gun drilling, for instance, CAMWorks added gun drilling functionality a year or two ago. They update the post processors to support that functionality in the mil.lib. So that one is changing with each new release of CAMWorks. And you'll see the list of changes down at the bottom. They always do like an update of the changes and things that they've done at the bottom of the program. The master.atr is a file that allows you to define an attribute so that you can create either new posting operations or new menu items inside of CAMWorks. So if you go to any of the posting tabs and you see things like absolute or incremental or coolant, and you've got your list of different parameters there for coolant, those attributes or variables are actually defined in the master.atr, and then they'll be defined again in the lib file, the postname.lib, to tell you what exactly the format of that list is, what's included in that list, which one is the default setting, and things like that. But the master ATR needs those values defined so that it understands they exist. The mil.t32 is really somewhat of a legacy file these days. It's mainly used it's a tooling file, but it's mainly used for plasma and laser machines to see if they've got auto indexers on the tool, the changers and stuff like that, all of the parameters specific to punch, plasma and laser machines, but that isn't really used so much anymore in the milling and lathe side of it. Looking at the compiled files, so when you compile the SRC file, that SRC file has library locations which define where your other files are, like your postname.lib and the mil.lib. It defines the location of those. So when you hit compile, you will get a postname.ctl, postname.lng. Now those two files are linked together in the background, so you can't open the file up and read any of the code. It will all come up as that weird kind of graphics and kind of compiled language if you're trying to open it in Notepad, for instance. But those files are linked together, so you have to keep them together and you cannot rename them. If you want to rename the post, you have to go back to the SRC, rename the post, make sure the library locations are renamed as well so that all the library locations can be found, and then recompile, and then the compiler will do it. If you just try renaming the post, the CTL file, you will break the post and it will no longer be able to find certain functions in there. On top of the compiled files, there's a few additional files. The PINF file is controlling the file extension, so the posted code file extension, so .cnc, .nc, .eia, .txt, all of those locations. So we can create a PINF file, which is basically a post information file, to tell it what the file extension is and where to find more information about the actual post itself. So it has the locations for the RTF files defined in that PINF file at the bottom. The postname.kin, so the kin file is only used for 4 and 5 axis simultaneous machines. It defines what that equipment is and the orientations of it. So if it's a head machine, if it's a head table machine, or a table machine, what are the angle limits of the rotary axes and things like that. But that's only required if you do simultaneous and you're using the multi-axis mill in 4 or 5 axis. And like I say, the postname _s.rtf and the postname _l.rtf are basically like WordPad files or text files, which you can put more information into it about how that post is particularly set up. So if someone has never used that post before, you can say, hey, if you don't set this, this is what work coordinate is going to output. If you do this, this is what's going to output in the code. So you can use that as basically like a little checklist or just more information about the post. And they will get displayed in CAMWorks in the machine post-processor tab. So, on to getting started, the kind of bits that we're kind of all eager to get into. So the first thing I like to recommend is create a local folder on your system called, say, CAMWorks Post or something, whatever you want to call it. Make sure it's local on your system. If you are using something like Google Drive, usually if you are using Google Drive as a backup, I will always copy it locally to my machine, make the edits on the machine on my local system, so that I've always got that one on Google Drive as a backup in case I've done something and I've messed something up. Always keep a backup. If you change something, hit save, you've got to remember all those steps that you go back to. If it doesn't compile because you've done something silly, then you will then have to go back and retrace your steps, refigure out, get it back to a stage where it will compile and go backwards. If you've always got that backup, you can never go wrong because you can always copy that backup into your system. Never compile from Google Drive. If there's network issues or connection issues to Google Drive, we've seen it cause some issues on our side, basically, where it's messed some of the posts up. So always copy them locally and compile them from your particular machine. The other thing that I always do is copy the mil.lib and the master.atr from the C drive UPG mil source folder. So like I say in here, go and copy those files to that particular folder. I have one on my desktop here that I've created, and I've just copied those files in. If CAMWorks doesn't update to the mil.lib and maybe something breaks in your particular post because it's conflicting with what you've already done, you've always got those backed up, ready, a way to basically go point it back to these particular files, and then you've not got an issue if you need to make a change. So always keep a backup of those away from the default installation files as well. The other things I would recommend is if you do want to control things like the file extension and the kinematics and add the RTF files, in the C drive, in the default basically folder in your UPG, there is a tutorial source files folder. If you go in mil tutorial source files and then choose the year, there's a bunch of the tutorial files in here, but you can copy these particular files out and then you can modify them as you wish, and then just rename them the same as the post, but keep the _L and the _S basically on the two RTF files. But these are essentially Word documents to tell you, if you've used the tutorial post, this will look familiar to you. This is more information about what the post is, and the PINF file, just come up on my other screen here, controls the file extension and the location of these. So copy those into your folder when you're starting here, basically, and then we'll rename them after we've got some source files in there. One of the other biggest things is when I do compile the code, where is my CTL file going to get created? It's a common issue. People will go, hey, I've saved this source here, but I can't find the CTL. Where's the CTL going? I can't find my post. If you go up to File, Preferences, this right here is where your posts are going to get compiled. So I've just changed it to my particular folder on my desktop here, so it will compile here. This also controls where the master.atr is in here as well. So make sure those are set up beforehand, and then make sure CAMWorks is pointing to that location so you're always updating using the same post every single time. So let's get started with creating a post in the UPG here. So if you've not got the UPG, you can download it from the CAMWorks support site. There is where you download the updates and everything else. It will be on there. If you have DVDs being shipped to you and things like that, it will be on the DVD as well as one of the options there. But essentially, when we want to start creating a new post processor, click on the new icon at the top here. There's a bunch of templates in here already, and these are just starting points. So Heidenhain controls, Fadals, Siemens controls. We're just going to use an example of a Haas. A Haas is basically a Fanuc, similar code, just a few little differences in there. But you can look at specific controllers in here. You can click on View Code and see exactly what it's currently set up to output in here. So you can see the current output is doing this safety line here. It's got a tool change here. Maybe we want to put in things like a preload. We've got our G43 here with our tool number, but our G42 and 41 lines are outputting with a 21 offset from the tool number. So we're going to go and look at that. And maybe we want to do some customizations to maybe the end of the code and things like that, and maybe add some more information at the top there. So we'll click OK, and that launches the template. So if we're going to go and create this for our VF3 here, we'll just basically put this information. And this information, you'll see the parameters are actually being changed down here. Now this is actually the variables in the EC editor in the text files that you will actually see. So anytime you're making a change to any of the parameters in this window, you will see this little window updating with those information. So if you're wondering, okay, what should that be for an arc center or an arc as the R values? Do I want I's and J's and K's or R's? What is the variable that I need to put in there? Just fire up the UPG, go into the EC editor, and then basically just copy the text across in there. Now this information here actually goes into your post window. So when you go into your CAMWorks, you fire up the machine and you switch to the post tab. When you go and hit select on the post, this is the information that gets put out to the code here. So that window pushes that information into here. The other thing that's important here, if any of you guys use incremental, the Z home here is where the Z home position is initially. So usually we don't find many people use incremental coordinates, but if you do set it in the posting tab, the starting point will be taking that Z home and going down from that position. So let's just go File, Save Source As, and I'm going to put it in my folder on my desktop here. So like I say, create a folder on your desktop, call it CAMWorks Post. I usually have an archive folder as well, so I can always go back to a previous version and just give it a name. So I'm just going to call it something specific, but give it something specific that you know this post is set up for that particular machine. If you've got 10 Haas VF3s and one of them's got certain functions, one of them's got different functions, make sure you can identify it, something unique to you, to know that that post is built for that particular machine. So we'll just give it the name here and we'll save it there. So the header tab, some of the important ones are in here. Am I using I and J or R's? So if I go to switch my arc centers to center, for instance, it's going to output I and J values like you see here. If I use radial, it's going to output my R as my radius line here. You can also control the arc quadrants in here. Some controls get a little bit funny on arc moves if they start and stop at the same endpoint, if they have to split circles out into 4 quadrants or 2 quadrants and stuff like that. Another main one in here is, do you want spaces? So do you want spaces in the output? You can check a box and you'll have spaces between each of the code. Makes it a little bit easy to read. Some controls don't like that. They want as much data crammed into that file size as possible. You can basically uncheck it and then it will output it just like below. If you are doing the multi-axis milling options here, you would uncheck this, go and say, okay, if I'm doing a 5-axis post, then you can go and say in here, CAMWorks 5-axis simultaneous. This is the kin file that you would be setting up if you're doing that. So that would be the kinematic file that you would go in and set, okay, my machine is a router. It's a head-head router, one of the gantry routers here. You just go head-head. What is the coordinate type? Which direction is the first rotary axis? Is it Z? Is it X? Or is it Y? what are the angle limits and things like that in here. So this is the kinematic file. We're not going to focus on that. We're just going to focus on a simple 3-axis post for now, but that's where you would go to define those options there. Now we get on to some of the kind of customization. So what do I want for sequence numbers? So when I go in to create the code, do I want my sequence numbers at the beginning of my code looking like N1 or N0001 or N1? Do I want them by tool so they only output at the tool line? We're going to look at that option and how we go there. Also, what is the maximum sequence number? So if you've got, I don't know, like a 3-axis toolpath where you've got a lot of code being produced, if you have it set to N999, it's going to basically reset it back to N1 right at the very, as soon as it hits that limit. Some controllers will error out on that, some of them won't, but just basically make sure that that's set high enough to what you want it to be. Now you saw in that template code that the compensation numbers didn't match. So currently the defined compensation number was set to 20. Now what that is suitable for is some controllers don't have a separate length and diameter column for their offsets in their tooling page. So what they have is just one big old column, and they've got, say, 1 to 20 is all of the tools, and we use those as our height offsets, and then maybe 21 to 40 is our diameter offsets. In this case, maybe our host doesn't have that. Maybe it needs to be set to the tool number, so T04 matches H04 and D04. So if you set that to 0, it will then match all of those up here. Another really useful one in this particular window is this little output debug. Say for instance you're troubleshooting some issues in the post, you're wondering, okay, where exactly is that code coming from? Sometimes you might have G43 lines coming on a few different locations. It could be the coolant is coming on, or the I don't know, a spindle speed or something like that, or spindle direction is coming on at some strange spot in the middle of the code. Which section do I need to go modify to go and look at that and edit that particular section? Well, if you hit the output debug in there, it will actually switch a function on the post where when you compile it and then go generate the toolpath on that new post, it will output into the code every single section that it's going through. So it will go through a start of tape section, it will go through then so the header and the safety lines here, go through a start of operation, then it will go, okay, tool change. There's nothing being output for every move, there's nothing being output for the rapid XY move, but it's going to then the rapid from tool change section, so we get a tool change line, then we get a G43 line, and then your feed line down. But it will list the different sections, so then you can go back and look them up in the code. So that's a super useful one. Once you have turned it on, you've found the section, go back, uncheck it, compile it, save it, compile it again, and then basically make sure it's off, otherwise you'll get all of this text in your actual code. Then you've got specific parameters to certain types of operations. So if we're looking at things like an operation where we're looking at a specific type of operation in CAMWorks, maybe a drilling or a tapping operation, or a 2.5 axis operation like a rough or a finish or something like that. In the posting tab of that particular operation, you might get a bunch of functionality that tells you, okay, turn it to absolute or incremental, turn it the coolant on to through tool, turn the rigid tap on or off. So the checkbox is in here. So just an example, going to your drill and tap here, if we check on the options for rigid tap, it will add the rigid tap functions into that posting tab. And then we have to go tell it in the sections area over here, which we'll get to in a little bit, exactly what that needs to do when you switch that switch. So you've got a bunch of different areas to control, okay, these options are on in this particular operation, these options aren't on in that particular operation. So things like a bore with dwell for your typical G88 cycle. Do you want your dwell function? Well, obviously, yes, I need to put in the dwell command and things like that. The next option is the setup window. So the way these work are kind of twofold. These little checkboxes here go to setup. So they get added to this list here called setup, which is actually the list you see when you go into the machine post-processor tab, you select your post. The next tab across is your posting tab. Now this list right here is corresponding to the list and fields that you enter here. Now you can enter the information into this list, but you have to then also do it in the sections area. So I'm going to show you an example of doing that, and you'll see what I mean about a two-stage process. Another one that's super useful is how do I insert a program stop or an optional stop into my code, and what code does it input? If you use these often for stopping moving clamps around, or you just want to insert a manual optional stop, so you can say let it run through the code, if the switch is flicked then we'll go and stop the machine, if not it'll continue. Check them on, and then basically what you will see is you'll get the ability when you right click on the operation tree in here, you'll get new post operation, and then you'll get program stop or optional stop in the list. Then you hit insert, and basically it will go into your list there. And you can add comments to that as well, so you can say the reason why you inserted the program stop. Now lastly, the sections tab. Now I just want to go back to here just to kind of explain a little bit more about the sections and the way the post is actually structured. So the post is really structured around the order of the G code. So if you think of it like reading the G code manually line by line, when you're going through it, you're saying, okay, in your head, you go, okay, that's the header, that's the safety line, this is the tool change, this is the rapid from tool change, this is where it's doing a rapid move down in Z, then it's feeding down in Z, then it's doing a line move, then we've got an arc move in here with the radius value. Then I've just chopped a bit of the code out here, and at the end of the operation, it's doing a rapid move up, and then it's going the last rapid before a tool change, and then it goes to the next subsequent tool change. This is basically the kind of sections that you see in the code. So when you're going into this window right here, start of tape is the header, tool change, you've got initial tool change, then subsequent tool change, then you've got your rapid moves, your first rapid move down, your rapid move up, you've got cut moves, line moves, arc moves, all of those. Then you've got all your drilling cycles with the rigid tapping and everything else in here. And then if you're patterning, doing some patterns in the drills, or if you're using like M98, M99 subprograms, this is where it would go if you're using assembly mode. So this is basically the sections area. We'll look at going and customizing some of that in a second here. But we're just going to kind of summarize essentially what we're going to go and change in this particular post. So the first thing I want to do is create a custom header with things like program number, program name, customer name, and programmer. The next thing we're going to do is go and create a custom safety line and home the Z-axis at the start of the program, so it's not just if someone's accidentally left it halfway up in the machine, it doesn't just start doing anything. We just want to send it straight up to the home position right at the beginning of the code. We also want to put out sequence numbers by tool, so I'll show you how to do that. We'll look at also doing a preload of the tool, and I just created a couple of images here just to explain a little bit more about the preload. Preload tooling, tool preloading is only really suitable for the ARM style tool changes, the one where you're switching the tool out to the same position in the carousel. If you've got the umbrella style changer on the left, if you start switching those tools out and putting different tools back in different spots, you're going to be cutting with the wrong tools pretty quick. So tool preloading is only for the ARM style tool changes, not where it needs to go back into the same spot in the carousel. But we're going to look at doing that. We'll say our house has got the ARM style changer. We're going to adjust the tool offset numbers to match, so T1, H1, and D1 for the length and height and diameter compensation is all set up. We want to turn on the rigid tapping, so maybe we need an M29 coming out in our code. And then we also, at the very end of the program, very common one, we want to bring the table to the front center so it's ready to basically unload the part, load the next part in. So we're going to do all of that stuff in the Universal Post Generator, the UPG. Then we're going to go and look at the EC Editor and we're going to create a new section in the EC editor to basically send the tool to the home position at the end of each operation. So if we were using a G91, G28, Z0, or a G53, G0, G90, Z0, we're going to put one of those in it and control section that always goes through. Every time it comes to the end of using that particular tool, it will then go up to the home position, then do the tool change, and then drop back down again. So let's go and do those changes here. So the first thing we're going to do is look at modifying the header in here. Now you'll see some of these are actually grayed out, these functions here, like program name. That's because I've not been through in here and checked them on. So if I go, hey, program name, say I want maybe part name, customer name, programmer. So I want all of these coming out, for instance. I just go and check the box in here. I can put in a default what it's supposed to be, and then when you go to your sections tab, you'll see that these now available here: program name, customer name, part name, programmer. So what I meant by a two-stage process is the first thing I have to do is check these on. That puts the items in the list so that I can then edit the list. The second stage is when I post the code out, where do they actually come in the code? So in this case, I want my %sign to start of program, I want my program number. Then right here, I want to go in and put the code. Now I just hit enter. Now the :T: stands for template. That has to be at the beginning of every line to tell it this is the format of the code. In this case, I don't want a sequence number. I just want, say, program number, or program names, for instance. It puts in the variable in here. And then I need to tell it to go to the next line. I just want each one of these on a separate line, so I do end of line. So that tells it to go to the next block. It puts a space in there so I can continue down and keep going. So I can go :T:, then I can go, say, customer name, end of line, :T:, programmer, end of line. And then I'll just delete that particular line here. Now, so I've customized this header a little bit, but maybe I also want to put out some more information here. So maybe I want to put in a G80. I can just look at this little keyboard down here, put in a safety line. I always want to make sure that G80 is cancelled before I start the program. Some of these codes are modal, as in once they're turned on in the machine, they're on permanently until you cancel them or switch them off. So things like can cycles, things like work offsets, you only call them out once, you don't call them out every single time you want to use them. But if that's left on in the machine and someone goes to start it up, you don't know what that particular code was left on in the machine. That's why we have a safety line. Set the machine up to have all of these values set as a default, as a basis. Turn all these settings off. Now we don't want that Z0 in here because we're going to put a new line in here that's going to have our G53. So we can go basically in here, :T:. Now I want a sequence number at the beginning of this. So I want my line number here, N. And then I want to output a rapid move. Now this is a prime example of the difference between modal and non-modal codes. I've already got a G00 right here. If I put just a G00 using this button right here, you'll see there's no exclamation mark. That means because it's already been output, it's already on from the previous line, it will not output again in the next line. To actually output it with the exclamation mark, you can just put in an exclamation mark manually, or you can switch this non-modal flag and then go, and it will actually force it out. It will hard code it into the code and force that particular G00 to come out every single time. So we can go through, there's no particular button in here for G53, but we can go G52, and then we can just modify it to G53. And then we also want G90, same again, we just for safety's sake, we'll put a G90 in there, and we'll put a Z0, and then an end of line. And that will just send it straight to the home position right at the beginning of the code, so the tool's way out the way right at the start when we're moving parts around and stuff like that. The last thing you want is a part or a table moving around when the the head is still down. So we've done our safety line, we've done our program header. The next thing we want to do is go and do the sequence numbers by tool. Now if we go back to the miscellaneous tab here, you'll see the sequence number by tool will set the sequence config to 3. Now this is the EC Editor variable. This is the post variable that's in the EC Editor. You'll notice it's the same if I use no sequence numbers. What essentially it does is it turns off all of the N numbers in the code, and then I have to go back in here and look at the tool chain. So if I just want sequence numbers by tool, I want to put in my tool sequence right here. So I'll leave the N in. It means that the N won't come out here because I've just switched it off in the code. But now this will output the tool number basically as the N number. So I can go in and search. If I've got, say, tool 8 used, I can go Control F, N8, and it will show me every single line with my N8 on it, and so on and so forth. So we've set our sequence number by tool up. But I also want to do a preload. So this is just a standard tool change right now. It's doing a T for the tool number, and then the MO6, and then it will output the tool comment, and then it will turn the spindle on and tell it the spindle direction, your MO3 or MO4. The thing that I want is I want the next tool loaded in, so I don't have to sit there waiting for the carousel to rotate. Remember, it's my ARM style changer. I don't want to have to sit there waiting for that carousel to rotate. Maybe it's on the other side of the carousel. It's just going to sit there wasting time. So the way I do this is I just copy this entire section into my preload, init preload tool change section. I hit enter, control. We'll put the N in just for completion's sake, but like I say, it won't be output because we just switched it off. And then I can hit next tool, end of line, and it will switch that carousel around. We also want to do the same for the subsequent tool change as well. So we'll just put that tool sequence in right here. We'll just copy it, paste it into our subsequent tool change, and then we'll go enter, colon, T colon, next tool, and then end of line. The next thing we want to do is make sure the tool number matches the height offset and the diameter offset. And that's just the simple fix, define compensation number. We just need to set that to 0. The other thing we want to do is go in and switch the rigid tapping section. So when we check on the option in the drill tap function here for rigid tap, it will add the options in the posting tab, in the sections tab over here for rigid tapping. So I just need to tell it what does that represent. What do I need to turn on here? So I'm just going to copy the existing tap cycle. And say, for instance, I just need an M29 in there on the line before. I will just output up here, colon to colon, and then we'll just put in our sequence number just in case we change our mind. And then we can just type in, if you don't see a code right here, you can either type it in manually or you can just go 29, miscellaneous M code, and then end of line, and remove that extra space in there. The last thing we want to do is bring the table at the end of the program to the very front center of the machine. And that's going to be in the, basically in the miscellaneous section here, in the end of tape here. There are 2 sections. You can also do a preload at the end of tape, so you can tell it, go to the first tool that I used in this program, or go to a hard-coded tool, so go to tool 1 every time. Some of those options are controlled in the miscellaneous tab here, preload tool at the end of tape, what tool to preload at the end of the tape here. In this case, we don't want to do that. We're just going to basically leave the end of tape sections. And we're going to switch this all to use the G53. Haas just released a video recently of them recommending the G53 method over the G91 just to prevent any upsets, problems with the G91 and the G90 switching back and forth. So we're going to basically say, okay, hard code that. So we want to force that G00 out. we can delete everything in between here where we want that G53 coming out, and then we want here Z0. So I think there's an extra line space in there, and also a G90 actually as well. So let's just go G90 here. And with the G53 call, we need to do it on every single line. So if we want to go, maybe our table is 4020. We know if we've jogged the machine to X20 or X minus 20, it will bring it to the front center of the machine. If you check that out on the machine, you'll need to check obviously on your specific machine what that value is. But then we can basically just copy this line here, paste it down there, and then we can go, hey, we want a Y0 and then an X minus 20 in here. And then basically M30 will end the program, and the percent will basically round out that program for us. We hit save in here. That saves our VF3, and then we can go File, Compile, and then we basically just point it to that folder. So you navigate through your folders. In this case, it's on my desktop. We point it to that Haas VF3, double click on it. It should say post compiled successfully. If you've done something, it will give you some errors, and it will kind of guide you through some of the steps on what is going wrong. Like if you missed an end if for an if statement, it will tell you there's something missing in this. Go figure it out. But it compiled successfully. The other thing is to also build a file and program a file that you would program the way you program it, so that you know it's going through the correct sections in the post when you compile it. So I've just got a program in here. You'll see here's the program. Well, actually, let's go select that post first. It won't show up until we actually have that post. So C drive, users, desktop, CAMWorks Post. We just hit select. So if you are making post edits, a common problem is we'll always send a post update back to someone and then be like, this hasn't changed. The first thing you have to do is go reselect the post. So just double click select a couple of times just to make sure it's taking that new post. You can't just paste it over the top and expect it to work. You have to select the new post, click OK, and then you have to generate toolpath because it needs to refresh everything. If you don't hit generate toolpath, it will still post the old code. But now you should see new post operation. You'll see the program stop capability or the optional stop that we can put in there. And it goes in here. We can right click and add comments to say move a clamp. The stuff at the top will get put out in parentheses in the code. The bottom stuff is just for reference here. But basically we can post the code here. Actually, let's just go look at the tab section. You should see now when we go to the posting tab, we've got that rigid tap function on or off. So the defaults will be on. That can be controlled in the EC editor. But you can see post, yes, up here. Let's just let it run through here. And we've got customer name, programmer, and maybe we need to do something with this this first one here. We need to edit the format of that. That would be done in the lib file. But you can see we've got some custom information out here. We've got the G20 line, then I've got our G53 line. We've got our tool preloading. We've got our H value. If we Control F and look, see if we've got our D value. Our D value is D4 for our tool number. Should just check that all matches and things like that. And then right at the end of the program, we've got our G53Z0, X minus 20, M30, and percent there. And if we go to a particular tool change, like say N2, let's go up from here. Oh, it looks like maybe I missed that for some reason. Oh no, here, right here, NO2, that's why it wasn't working. So now I can basically put that in there, and I can search for NO4, NO8, NO4, and it will take me right to tool 4, basically. So the other thing we're going to do is look at the EC editor. So the EC editor, the easiest way to get it to work here is just shut out of the source in the UPG. Click yes to it, and then go browse to that location. Go to your desktop, go to your posts, and you'll see, because I set up the file location, it compiled the post into that location. Whilst I'm here, I might as well go in and copy this across here, so I'll just change the PINF to this name. Sorry, misclick that one. Put that in here, put that in here, and then we'll just edit the PINF and go and tell it this is the post name. Maybe we want NC. Notice there's no dot in here. That's another one that always gets people. They put 2 dots in the code because they set this up incorrectly. And then just save that. And we've got our backups down here. So those have now been edited. We can basically go and change any of these to say custom post info underscore long format, so you'll see where this will come into play. And then short format, we can just go description short format, if I could spell. And when I go and select on the post in here, you'll see this is the short format, and then the more information here comes up with the long format information. So you can put information about your post, the way it's configured, and everything else in there. So whilst we were there, we just thought I'd do that for you. But let's go and load up the SRC file and the LIB file into the editor. So here's the SRC file, here's the LIB file. The other thing that I will usually open up is I'll go to my UPG, mil source, and my mil.lib. This is the generic one, remember, that CAMWorks updates. So basically, if I'm going to do some work in here, I maybe want to create a custom section where it always goes through at the end of the operations. So you'll see your SRC file it's a text editor. Everything in blue here is something that's calculated by CAMWorks and passed to the EC editor, so you know that it's a variable that CAMWorks is calculating. You've got your host VF3, your machine name, your control, your library locations, and this is where you would update if you change the name of it. Just make sure these library locations are pointing to the correct location here. Your setup name, thinking like your customer, your program, this is where that the setup tab in the UPG comes into play. This is where it gets added. You'll see our rigid tapping, our tapping sections here. And then you've got all of your operations. So we've now got our program stop in here. You've got your start of tape with that program name. So maybe we'd just put, that was the one I think without the parentheses around it. So we could put that in parentheses. And we've got our custom safety lines and everything else in here. So we could just delete that little bit out here. We've got our preload. Now, at the moment, there's end of operation or end of tape down here, but we want it to tell it to go to a specific section of code at the end of every operation, regardless of whether it's a drill operation or a milling operation. We want it to go to a specific point of code. So we need to copy some information from the mill.lib into the host vf3.lib. So this is the way, if you are making changes to the calculations, you'll see in here, this is listing all of the calculations. This is what CAMWorks updates with each release. They tell you what they've been changing and what they've been working on in here. But if I want to change the end of operation, I go find calc end operation, and I can go and customize it. But the way I do it is I basically copy that section from the mill.lib and I paste it into here, into the machine specific lib, to say it's specific for that particular machine only. If I'm working on 10 different posts, I might not want this for every single post. So think of it like that. The machine specific lib is only specific changes for that particular machine. If it finds the same section name in here as it is in here, it will always use this one instead of the one that's listed here. So this is like an override, a forced override. And then we can add some custom calculations to it. So the C stands for calculation, just like the T stands for template. Usually I will put in information here about the date that we modified it, so 9th of August 2017, so I know exactly when I modified it. And then we'll go and put in some calculations. So in here, what I'm going to do is if the next tool, so you'll see as soon as you start typing, right, and you get a variable that CAMWorks recognizes, it will turn blue to say, okay, I recognize that tool, or that particular parameter. Is anything other than the current tool, then go to the next line, step in, and then if the next tool is greater than -1, which tells it, okay, the -1 is the last tool in the program. So if it's not the last tool, because we want it to go to end of tape instead of the end of operation that we're going to call it, then next line, call end operation. And this is a custom section in the SRC file that we're going to go and create. So anything with calc is a calculation section. So section equals calc and then a name, that's going to have calculation information in it. If it's call without calc in it, like call end operation like you see here, that's going to go to the SRC file. And then we need to close these out with an end if to say end that one, and then finally end if right here to close out the first one. Now that's going to call an end operation section, but we need to save it, and we need to then go and define where that end operation is. So what I'm going to basically do is just copy this line right here and then modify it. So we'll just put end, and then in these you have to use the underscore operation, and we want it to basically go to the home position in Z. We also want it to turn off the coolant, so we'll just go :T:, N, and then we can put in our M09 to turn off the coolant, and then EOL to tell it the next block. So you can do the manual edits in here just like I'm showing you right now. But in this case we don't want it to go to that X0, Y0 at the end of every operation. We don't want it to bring it to the front of the machine at the end of every single operation here. So all we're going to do is basically tell it to turn the spindle off. So we'll just go N M05, end of line, and then we also might want a optional stop right here. So we might put in M01, so that at the end of every single operation before a tool change, I can just flick the switch if I needed to, and it will stop automatically at the end of every single one. So I just save it, and then I can go back, close this down, compile it, file, compile, point it to my location. If it compiles successfully, great. If not, I've done something wrong, I need to go fix it. And then basically go back in here. I'm just going to reopen this here, make sure it takes generate post. Now you'll see the NC, because of the PINF file, is being set automatically. I don't have to switch it every single time. And you'll see at the end of every single operation here, before the tools change, there's going to be that block of code here. So right there, look, you've got your Z move, then the coolant was already off at this point, so that's why the coolant line didn't come out, but there's a G0, G53, G90, Z0, M05, M01. And then we've got the next one here. We could also put in a space in there. If you do want to do kind of spacing out the code in the SRC file, you would just put in a double space. So if I wanted to go now back to that section and edit that section, make sure it kind of splits it out, you can just go :T:, space, space, EOL, save it, compile it, and then you would get your space out in the code, so it kind of breaks it out a little bit more so you can see where the end of an operation is a bit easier. Obviously there's a lot more that can be done with the post processor. We do offer custom post writing services as well, but that's the end of the presentation. Obviously there's a lot to talk about with posts and all the possibilities and everything else. But thank you very much for attending. If you're interested, there's some other webinars that are coming up next week, the week after. We've got some PDM, so data management tool webinars. So check out the main location on the events page on the webinar Wednesday, and always check that events page for any new events. We have a lot of different 3D solution spotlights, new webinars, and different content being put up there all the time. So just go and check that out. And with that, thank you very much.